learners, welcome to Math 2 class with Teacher Marian. In this section, we will talk about the first lesson in Quarter 4, Module 3 with the topic, Interpreting Quartiles. The interpretation of data helps researchers to categorize, manipulate, and summarize the information in order to answer critical questions. The importance of data interpretation is evident, and this is why it needs to be done properly. So for this lesson, our main focus is to interpret quartiles. First, let us recall that the quartiles are the score points that divide the distribution into 4 equal parts. Each part represents 1/4 or 25% of the data set. In this illustration, if we look at it going this way from left to right or from lowest to highest, we can say that 25% of the data has a value less than or equal to Q1. 50% of the data has a value less than or equal to the median or Q2. 75% of the data has a value less than or equal to Q3. On the other way around, we can say that 25% of the data has a value greater than or equal to Q3. 50% of the data has a value greater than or equal to the median or Q2. And 75% of the data has a value greater than or equal to Q1. Make sure you are able to understand this part because it is an important information needed in interpreting quartiles. Now, let us proceed to the first example. The following is the data obtained by 12 students in a summative test in Mathematics 10. Find the value of Q1 using Mendenhall and Sinsich method. This problem is an example of ungrouped data, so we will be using these steps to get the value of Q1. Step 1. Arrange the data in ascending order. Step 2. Find n or the total number of elements. The value of our n here is 12. Step 3. Calculate the position of quartiles using the formula. Since we are looking for the first quartile or Q1, then the value of our k is 1. And for the n, the value is 12. Let us substitute the value of k and n to the formula. By doing the operation, we were able to arrive with an answer of 3.25. The computed value 3.25 becomes 3 after rounding to the nearest integer, since the decimal part 0.25 does not fall halfway between the two integers. This means the lower quartile is the third element of the data. So, Q1 is equal to 37. So in this problem, the value of our first quartile is 37. Now, let us have an illustration for us to easily interpret the data. Based on the illustration, we can interpret that 25% of the students got a score of less than or equal to 37 in their summative test. On the other way around, we can also say that 75% of the students got a score of greater than or equal to 37 in their summative test. Now, let us proceed to the second example. Based on the table of scores, if the student got a score of 41, does he belong to the top 25% of the class? This problem is an example of grouped data, so we have to follow the steps discussed in Module 2, Lesson 1, Quartiles for Grouped Data. Before getting into the steps in computing the quartile, let us first identify what is asked in the problem to know what in quartile we are going to find. Thus, the student who got a score of 41 belonged to the top 25% of the class. In a distribution, the top 25% lies above the upper quartile or Q3. So in this problem, we are going to find the value of Q3. For the first step, we have to complete the table. Make sure you are able to watch the video lesson in Quarter 4, Module 2, Lesson 1 to give you the explanation on the process in filling in the entries in lower boundaries and less than cumulative frequency columns. In addition, the value of our n or the total frequency here is 50. after summing up all the entries in the frequency column. Next is to determine the quartile class interval using the formula. Remember that our K is the nth quartile and N is the total frequency. Since we are looking for the third quartile or Q3, then the value of our K is 3 and N is 50. Let us substitute the value of K and N to the formula. By doing the operation, we were able to arrive with an answer of 37.5. This means we need to find the class interval where the 37.5th score is obtained. Note that the 28 to 38 scores belong to the class interval 36 to 40. So, the 37.5th score is also within the class interval. The Q3 class is class interval 36 to 40. For the last step, let us calculate Q3 value using the formula. Let us perform the operation by substituting all the given in the formula. Remember that the value of the expression Kn over 4 can be found in step 2. So for Q3, the value of the expression Kn over 4 is 37.5. By doing the operation, we were able to arrive with an answer of 40.27. So in this problem, the value of our third quartile or upper quartile is 40.27. Now, let us have an illustration. Students with scores belong to the top 25% of the class lies on this part of the distribution. So we can interpret that 75% of the students have scores less than or equal to 40.27. So, 25% of the students got a score of greater than 40.27. Since the score is 41, therefore, the student belongs to top 25% of the class. And that's all for this lesson, Interpreting Quartiles.
Maraming salamat sa panunood, mga kaalamat!